Okay, so let's take a look in this area here where we're going to do the normal gas exchange. Okay, so let's zoom in here a little bit. Yeah, that's probably pretty good right about there. Okay, so we're going to inhale some oxygen, and I'm doing red. And we're going to inhale that oxygen, and it's going to pass by the epiglottis, and we're going to stay on the patient's right, okay? And that oxygen is going to go between the vocal cords, through the glottic opening, down the trachea, and I'm going to redraw it here, okay? And it's going to go, well, it's going to go down both the right and the left main stem bronchi, but it's going to go down the right bronchus in this example. And it's going to travel down here through this bronchiole, right past the smooth muscle, because the smooth muscle is very, very relaxed. And we're going to collect oxygen here in the alveoli. Okay. And because we have a high concentration of oxygen in the alveoli and a low concentration, well, actually we have none, well, not realistically, but in this diagram, we've got none here. We've got high concentration, low concentration. Oxygen is a small molecule. It's made up of 2 atoms, and it is uncharged. Therefore, it meets the criteria for being able to diffuse easily through the phospholipid bilayer that makes up the cell membranes of these simple squamous cells. Remember, simple squamous cells, simple squamous cells. So this oxygen is easily going to diffuse from a high concentration to a low concentration into the capillaries, and that oxygen is going to get carried to the body, and we will learn about that. No, not to the boy, to the body. And we will learn the specifics about that when we do the circulatory system. Okay. Okay. Now, because we're doing cellular respiration, we're taking in oxygen and glucose, and we're producing CO2, water, and ATP. The whole reason we do cellular respiration, we're going to start to get a buildup of carbon dioxide in the bloodstream. Okay. So here we have, so this is from the body. Okay, there's going to be a whole bunch of CO2, 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 CO2. High concentration of CO2 in the capillary coming from the body. Low concentration of CO2 in the alveoli. So what the CO2 is going to do is it's easily going to diffuse down its concentration gradient from high to low. And it's going to end up in the alveolus. So because there's a high concentration of CO2 in the capillary bed coming from the body and a low concentration in the alveolus, the CO2 is going to diffuse down its concentration gradient from high to low, and we are going to exhale that CO2 out the bronchiole, up the bronchus, up the trachea, through the glottic opening between the vocal cords, and we're going to exhale that CO2, and we can actually measure how much you exhale. Typically, we're going to measure it pressure-wise. And typically, normal healthy set of lungs, normal healthy heart, and normal healthy blood vessels will be exhaling, and normal healthy patient will be exhaling between 35 and 45 millimeters of mercury of CO2, and we'll get into that a little later. So this area here, top left-hand side of your paper, which actually would be the right upper lung of your patient, this represents normal gas exchange and circulation. Okay.